All right. So your test is on Thursday. 10 questions. You're allowed one note card for notes. I'm going to go over things that are very similar to the test today. So if there's things that I go over and you're like, I'm not going to remember that, that's what you write down on your next card. Okay. There's nothing going to be like real tricky. Like if I don't go over a log problem, for example, the log problem is not going to show up on the test. You're not going to need to use those rules. So I'm not going to put something on the test that I don't go over something similar to in class today. All right. So, all right. I know this was the biggest question on the homework, so I might as well go over it first because it's the first question on the test. So this question asks you to do a couple different steps. It wants you to find the slope of the secant. So we're looking for that slope as basically the limit goes to 0 for the slope. But they do it in a way that's kind of confusing because they ask you to come up with all the points first and then come up with the slope. So on this one, we're looking for the slope at this point right here at 5, -3. So in essence, we're looking as the limit goes to 5. So which values of x should I plug in for my points? If I'm looking as x goes to 5, which values should I plug in? Okay, so if I'm looking, remember, we're looking for the limit. Is 1, 2, and 3 going to get me close to what it is at 5? Remember, when we're looking for the limit, we're looking for points that are extremely close to it, right? So 4.9, like those, like really, really close. So 4.9, 4.99, 4.999, 4.9. And then on the other side, the 5.01 and the 5.1. So you're looking for points extremely close to it. Okay. So now we need the y for all this. So basically for these points, we've got the x, we need the y. You are going to be allowed to use Desmos on the test, so use Desmos. So I typed in the point or the equation for it, and then you click this little gear and you can get the table. So right up at the top of Desmos, you see that little gear? If you click it, click the table, you'll get this table. And then you can plug whatever values you want in for x over here. So I plugged in all the values that we just plugged in. So those are my values. I'm not going to expect you to sit there and do it out by hand, every problem. It's not worth your time. So the first thing we have to do is we need to find those points. Those are the points on either side of 5, -3 that I'm going to use. Okay, does that make sense? Now I want to find the slope of each of those points to 5, -3. So what's the equation for slope? Yes.
So it says correct.
Yeah. Your y value. Because then when you do your slope, you're gonna, and honestly, if you're 5, I'm not gonna be overly confident, like concerned with exactly 6. When you do WebAssign, they want you to come up with enough decimal places so that when you round correctly at the end, you get the right answer. So on the like this one, 3.003, after that's 0, so you didn't need to have those extra points there. So I'm not going to worry about you not saying, oh, I don't have the extra zeros there at the end, like those type of things. So I'm a little more lenient on the test than what WebAssign is on the actual homework assignment. All right, so we've got these points. What's the equation for slope? Yep. So there's my slope equation. Oh yeah. I taught high school for decades. I guarantee you I can read your handwriting. There is one thing I'm just going to tell you right now. Your tests, I don't care if you do it in pen, it cannot be fluorescent colors. No fluorescent green, no fluorescent pink. I will literally not correct your test if you do that. Pencils, black pens, blue pens, fine. No fluorescent colors. They hurt my eyes. All right, so we need to find our slopes. So again, I'm going to save myself some time. We're going to use the Desmos calculator. So the scientific calculator, you can do this any way you want. I'm just doing this because it's going to save me time right now. And I'm showing you cool ways to use Desmos. You can plug formulas into Desmos in the scientific calculator. So I put the equation for the slope, m equals y2 minus y1 over x2 minus x1. And then you just put each of those as separate lines. This way I can type whatever I want into those lines, and it's going to give me my answer at the top. So for example, in this one, it was 4.9, and then it was, and there's my slope. So I now have my slope at that point. It's 3.33333. And then I go back. 0.30303. And I plug this one in. And I get 3.0303. .999, and it was 0.003. 3.003. And then 3. So you're defining the slopes for each of those as it goes there. Go to the Desmos scientific calculator. Yeah, you can do it in the graphic calculator. It's just not nearly as nice. But yeah, if you just go to desmos.com, it's a scientific calculator. That gives you this one. All right, now I'm going to come up with the other ones. I believe they actually just reflect. Right. 2.987. Oh, that was a mistake. And that comes out to be 3. 3.003, 3.0303, and 3. Oh, I lied. I was wrong. I figured, this is what happens when you don't do all your workout and just actually guess. I'm like, all right, let's go look. Yep, nope, didn't. All right, let me finish them then. Now you know what not to do. 2.97. 7. 2.97. 3. 2.727. Okay. There's our answers now. So what's the slope as we get closer and closer to 5.5 negative 3? It's 3. So the limit as x goes to 5 of my slope is 3. Okay? Yes. Oh, it looks like you had a question. No, you're good? Okay. All right. So that's basically if you look at the wonderful homework problem. So the second problem, that's this one. That's basically what they're asking you to put it there. Oh yeah, I've done nothing yet. I'm going to finish this up. So that's B. I'm going to do C now. I think it's due Thursday, technically. So to be completely unfair and honest, I don't look at your grades for the homework assignments until the end of the marking period this semester anyway. So if you do it late, I'm not marking it wrong. It is in your best interest to do it on time because you actually practice it and it helps you practice for the test. So it is definitely in your best interest. But if you do it in May, as long as it's done before the end of the semester, you're fine. So I will put in, so like next week when I do the grades for the tests, I'll put in your tests. I'll put in the homework that you have there, but I go back and change that afterwards. So, all right. Yes. Yeah, all the grades will be on Blackboard afterwards. Yeah, I got to update those. Because that's the only way you actually can see your grades on a regular basis. All right, so the last part of this question, they want you to come up with the equation for the line. So what's the equation for a line? Okay, so we got two different ones, right? And actually, either one will help you. So you could do the point slope equation, which typically everybody remembers is the y equals mx plus b. Although in this case, I don't have the slope intercept. I don't have the intercept. So that equation, I'll have to do an extra step to plug back in. You can't. You could also use the point slope equation, which is the one you just said. So that's the y minus y1 equals m times x minus x1. So we've got y minus negative 3 equals 3 times x minus 5. So y plus 3 equals 3x minus 15. So y equals 3x minus 18. And that's my equation. So the goal of what you're trying to do on this problem is you're looking for, in essence, the tangent line at that point. So, because as of right now, we can't do it using limits and the equations and stuff because you haven't learned how to actually do that part yet. We need to do it in terms of looking at the secants and doing the limit as it goes to a single point. And that's what they're doing here. So, starting on next Tuesday, we'll actually look at how to actually find that the other way. A lot easier, by the way. All right. So, any questions on that front? Simple enough? The next question you're going to have is a graph. And there's going to be a few limit questions on it. So let's see, what's the limit as x goes to -3? What's the limit as x goes to -3? Why doesn't it exist?
It's not continuous.
Okay. Does the limit have to be continuous?
No.
Yeah. So the limit, remember, the limit's telling you what's happening as you get closer and closer to the point, not what happens at that point, right? So in this case, if we're looking at it, remember, we can look at it from either direction, right? So if we looked at the limit as x goes to -3 from the left, that's here, right? So what's happening as we go to there? We're going to 4, right? And if we looked at it from the right, on this direction, we're also going to 4. So the limit as the whole thing goes to 4. Now, h of -3, that does not exist. So plugging in the value doesn't exist at that point. So, next part of this question, you already actually answered it. You said it's not continuous at that point, correct? Which is good. We know it's not continuous at that point. Now, is it a removable discontinuity or is it a non-removable discontinuity? It's removable because we can come up with the value at that point. Okay, so a limit, when the limit exists, we can remove that discontinuity by plugging a value into there. Okay. Now we can do it a few different. In this case, it's a piecewise function. We literally can say x when h of -3 equals 4 when x is -3. It's like that would solve the problem there. It would actually remove that discontinuity. What about the limit as x goes to 0 of h of x? Okay, so that one does not exist because it's going to 2 different points, right? What about the limit as it goes to the from the left?
1.
That's 1. What about it goes from the right? And that's -1. Also notice that's an open point, right? So in that case, it's the same concept there. It's going to that point, but it doesn't actually equal that point. What does h of 0 equal? It equals 1. Okay, but that limit doesn't exist because it's going to 2 different points. Is this, what kind of discontinuity is this? Is it a removable or non-removable? This one's non-removable because the limit doesn't exist. It's going to 2 different points. Okay. Those. What's the limit as h goes to 5 from the right?
3.
So that's 3. Does that make sense? Because if we're going this direction, it's going to 3. What about from the left? Why? He's like,
Because
why do we always ask me
it
why?
looks like it jumps.
So in this situation here, what's that doing? It's oscillating. So because it's oscillating as I'm getting closer and closer to that point, I can't get to a specific value at that point. So you're right. It very well could stop at 3. However, as I'm getting closer and closer to it, it is literally bouncing back and forth. So I can't tell if it stops at 3. So in that case, that value does not exist, which And since one of the sides doesn't exist, that means the entire limit does not exist. Okay. Since there's no point there, I would assume if you plugged in a value, you would get 3. All right. Yes, questions? Any questions on this type of problem? Okay. All right. The entire rest of the test is just limit problems. I give you the limit, you find me the answer. Yes.
Is there going to be like that word problem that we had with?
No, I did not put that word problem on the test. The very first one, the volume one?
Yeah.
I didn't put that on the test. All right. The hardest part of the rest of the questions on this test is that they're just find me the limits. So we've done a bunch of different ways to do that. And I will tell you right now, the vast majority of the tests, that's going to be the hardest problem, because like the next test is going to be find me the derivative of a whole bunch of problems. And you're going to have to figure out which method we're going to use to do it. So this is the first one. How would you go about doing this? What would you like to try?
0 for X.
Why should we always put 0 in for X first?
See if it exists.
See if it works. It is very possible that it will work. So always try that first. If it doesn't exist, then we have to do some work. But always try that part first. So there are some situations where plugging in the value won't work. Most of those ends up happening in like piecewise functions or when you're going to infinity. You can always verify by just doing the graph of it and see if it makes sense. So like this one here, if we plugged in 0, we would get what? Cosine of 0, which is 1. So if we look at the graph for this one, just to verify and make sure that what we did there makes sense. So is it cosine?
Graph that.
Huh?
That means the graph that.
Yeah. So if we look at this graph here, we can see, well, it looks kind of crazy, but as we get close, as we zoom into the 0, we can see it definitely just goes to 1. Yeah. And like even on this one, when if we did this one, if this one was, say, the limit as x goes to infinity of cosine of x to the third plus 3x. So when we're looking at this one, if you plug in infinity, it's okay, it's cosine of infinity. Well, what's cosine of infinity? Cosine doesn't go to infinity.
1 or negative.
It's going to be 1 or negative 1, right? Or any number in between those, right? We don't know. It's going to keep bouncing. So this case, that does not exist because we don't know what it's going to. Since infinity is an arbitrarily large number, if I stopped at 1,000,001, that's going to give me an answer. If I stopped at 10 billion, that's going to give me a different answer. If I stopped at a Google, that might give me a different answer. Okay, so we can keep getting bigger. It's going to give me different answers. And if I add 1 to it, it's going to give me a different answer. So since it's not going to a very specific point as we go to infinity, that does not exist. Okay. Yeah. So there's some of the problems, like this one, just plugging in zeros, like, okay, that there's no other way to explain it. Like there's no other way to do a bunch of extra work to show that that works. That one just works. Same thing with like does not exist. All you would say is it oscillates. That's fine. Yeah.
Like, would you-
No. For what? Infinity or zero? If you just did the limit as x goes to 0 of x to the third plus 3x, that goes to 0. Which actually is one of the rules, remember? So we can, since cosine's continuous, I can change that problem to the cosine of the limit as x goes to 0 of x to the third plus 3x. No, it works only when the function is continuous. Function has to be continuous for that to work. So cosine's continuous, therefore it works. Yeah. Because the function's continuous, and as x goes to infinity, that goes to infinity. And then I would look at it in terms of the cosine of infinity, because I know the value of that inside there is infinity. Very good questions. Okay. What about this one?
By the top and bottom. Here. Of the numerator.
All right. So if we plug in 5, what do we get? We're divided by 0, right? So it doesn't work. Okay. So we can't plug in 5 and get the answer. All right. So the method that we use to kind of get rid of those square roots and work things out is a conjugate pair, right? So let's try the conjugate pair. And this is where I said, like, when you're writing your test, keep all your work, because like if you try something and it just doesn't work, it might have well been the right way. You just made a little mistake in it. So try things. You might not always get it right the first shot. All right, so I'm gonna do 3 plus the square root of x plus 4. And 3 plus the square root of x plus 4 at the bottom. So that means the top becomes 9 minus x plus 4. And the bottom is x minus 5 plus the square root of x plus 4. So remember, it's the difference of squares, so it's literally just the square of each one with the minus between it. All right, I still can't plug in 5. What do I do now? What will be your next step? Yeah. Yeah, let's simplify the top down. So 9 minus 4 is 5 minus x. Okay. Still can't plug in 5. Yes. Why?
Get rid of it.
So how would you know to do that? What gave you that clue? Because I guarantee nobody else in this room would have thought of that. Totally correct, by the way. Absolutely the way to do it. But how did you actually come up with the reason why? It is. All right. So if you're looking at the top and the bottom of this, what do you notice? On the bottom, I have x minus 5, right? On the top, I have 5 minus x. Those are very similar things, right? You would think, okay, I want to somehow get rid of those two things because they're similar. What's the difference between them? They're opposite signs. So what can we do to change signs? We multiply by a negative. So if I multiply the top, well, actually, I'm not multiplying the top by a negative. I'm actually going to pull out a negative. So if I pull out a negative, this becomes negative 5, and that becomes plus x. Right? Would that give you the same thing below it? And then if I reverse those, it's now the same. This is where your algebra skills and those little tricks and things come into play. And shake it like I would never have thought of that. You're absolutely right. That's why I said when she kept like nobody else in here would have come up with that off the top of their head. It's fine. This is why we do these review problems. When you're looking at, notice I didn't say I really didn't multiply the top by -1. I factored something out. We can always take something out of a problem. Even if there's nothing like looks like I can take out, you can always take out a 1. Okay. So the key piece is every step going to bring me back to the previous step? So if I was to FOIL this back out, if I was to multiply this out or distribute it back, would I get back to that original problem? Yeah. So mathematically, what I did there is correct. Can I just reverse addition? Yeah, because that's commutative, right? That's one of those rules you learned way back when, that you can just addition, you can just switch. Okay. Technically, you can't switch subtraction. We're actually moving the entire signs with it. That's why it actually allows me to do that. So now I have this. I have -1, x minus 5, over x minus 5, 3 plus the square root of x plus 4. Now I can cancel this out. And 2/3 of the class, this will be written down on your index cards. I can pull out a -1. But this is one of those problems that, like, I could easily have seen you doing that. When I'm going back and looking at the test, I could easily see people have done that. Your answer would have been exactly the same, except you were off by a sign. Okay? And when I go back and look at it, that's a little bigger than just a sign error because it's actually a mathematical error in there. But I know why you did it, and you'd get points taken off based on that instead of just giving me the answer with the wrong sign, not knowing why. Okay? All right, so now we have -1 over 3 plus the square root of x plus 4. Now can I plug in 5? Now I can plug in 5. So the limit as x goes to 5 of -1 over 3 plus the square root of x plus 4 is what? -1 over 6. All right. Keep closing the screen instead of start switching it. Okay, what type of problem is this? This is a piecewise function. The key with the piecewise function is when you're looking at the limits, you have to decide which one you're looking at. Okay. So the first one, the limit as x goes to 0 from the right. Which one am I looking at for that one? Well, that one's greater than 3. So if we're looking at 0, we're going to look at the first or the second one, right? So second one's coming is greater, so that's going to be the one we're going to look at. So A is 3 minus x, and if we plug in 0 to that, we get 3. What about B? We're coming at it from the left, 0. At the top one. So square root of negative x, plugging in 0, goes to 0. C, the limit as x goes to 0. Why? Right, those two are not the same, so this one does not exist. If they were the same, it would exist at that point, but since they're not the same, it does not exist. All right, now we're looking at the 3's. 3 from the right. Second or third? Which one? The last one. So x minus 3 squared. If I plug in 0 or 3 to that, what do I get? 3 minus 3 is 0. 0 squared is 0. E from the left. Which one am I looking at there? Second or third? Second. And that would go to also 0. So the limit at 3 equals what? 0. So where is this function discontinuous? Huh? It's a discontinuous at 0. Is it discontinuous at 3? There will be a couple questions on there that asks that. Yeah. Yeah. I think the one I have it on is the actual graph one. Yeah. That's what I said. I think the one I have asked that question on is the graph. So, is it discontinuous at 3? What does it equal at 3? Are you sure?
It doesn't. There's no.
It's keeping
Oh, there's no.
Is there one that has equal to? So it doesn't equal 3. It doesn't exist at 3. The limits exist because it goes to a single point. But since neither one of them equal that point, it's an open circle. Therefore, it's actually discontinuous at x equals 3 too. That will not be on the test. Don't worry. The 0 is, yeah, the 0 is non-removable. The 3 is, huh?
If they had 10 and x equals 3, then it would be just a jump point.
Yeah. It still would be discontinuous at that point, but it would be a jump discontinuity and it still could be removable. Or if they just put a little line there, it's now continuous at 3. It's not even discontinuous. It actually continues. Even though it goes to two different, it's because it's going to that point and that point exists at that point, it is continuous at 3 at that point. So yeah, if they had added 1 there, it would be a jump discontinuity. I do not believe I asked if it was a jump discontinuity in the test. No, it was just, is it removable or not removable?
And removable just means we can find it.
Yeah, yes, the limit exists. So you can actually do something to remove it. Because if the limit exists, if I put something there, it would actually be continuous at that point all the way through. So that's the difference there.
And not removable would be if it doesn't exist.
Right, because it's going to 2 different points. So there's no way for me to be able to somehow stick those things together.
Oh, yeah.
I'm flipping between like 5 screens now when I'm copying things and I keep getting mixed up which screen I'm on. All right. What about this one?
This one hasn't lost.
Mine-
I've been waiting for this.
The answer is -16, yes. Why?
I tried writing them on.
Okay, so we're going to 0, right? So these are absolute value problems, correct? Okay. So as I'm getting closer and closer to 0 from either direction, what is the value of the absolute value of 8x minus 7? So if I plugged in 0 to that, what would I get? I'd get -7 inside the absolute value, right? So I somehow have to change the sign of that, correct? So if I was going to change that, I could rewrite this as the limit. Actually, I'm going to do it underneath. Because as I'm getting closer and closer to 0 from either side, that value is going to be negative. Okay, because the 8 is going to be less than the 7 in that respect. Okay. What about the other one? So the absolute value of 8x plus 7. Is it the same thing? What happens as I get closer and closer to 0 for that one? Is it positive or is it negative? If I plug in 0, I get a positive, right? So as I'm getting closer and closer to 0, that 8x is going to be less than the 7 either way. So therefore, the 7's overruling it, so it's positive. So I can just get rid of the parentheses or the absolute value for that respect. You're not. You're not getting rid of the absolute value. You're understanding what the absolute value is doing at that point. So if we're looking at the absolute value switches when it's negative, right? That's the point of the absolute value. It removes the negative sign. So if it's positive, I can just drop the absolute value sign and get rid of it. If it's a negative, I really have to take whatever the answer is and multiply it by a negative sign, because that gets rid of my negative inside the absolute value, correct? So if I look at, actually, like the absolute value of x. If x is less than 0, that's going to give me the same answer as negative x, right? If x is greater than 0, I would just have to do the x. So I'm not really getting rid of the absolute value. I'm evaluating it in essence. So on this one, when I'm looking at it, this part here, as the limit goes to 0, the 8's getting smaller and smaller because I'm multiplying it by a smaller and smaller number. So therefore, the negative 7 is really taking over. So since that's a negative, I have to multiply whatever my answer is by negative to get rid of it. That's where that negative sign comes from there. That makes sense or no? Why am I getting rid of it? Oh, you'll see in a second why I'm getting rid of it. Because now I don't have absolute value, so I can take care of my parentheses. So I have negative 8x plus 7 minus 8x minus 7 all over x, which is what? Negative 16x over x. Now I can get rid of the x. So the answer is negative 16. So that's why I had to get rid of the absolute value, because I can't work with an absolute value. An absolute value is in essence a piecewise function. It has those two different directions depending on what the domain is.
If the limit was to a different number and one of them was underneath that number, it would still work the same thing.
Yeah, so if the limit was to a different number, you would still have to do the same thing. However, depending on how the absolute value worked at that point, depends on if you'd get rid of it or not.
So if it was to the limit of 1, you would have to, could you do this problem to the limit of 1?
Yeah.
Because that would make the first absolute value not have negative, correct? Not negative.
So it's very possible this is not going to work, but we'll see. All right, so if I did it to 1. I don't know if it's going to come out to be an actual value. That's the question I have. All right. So the question is when does 8x minus 7, when is it less than 0? So if I was to solve this, 8x is less than 7, so x is less than 7/8. Right? So anytime x is less than 7/8, I would have to switch that sign. Okay, so 0 is less than 7/8, so I had to switch the sign. Is 1 less than 7/8? No. So I don't have to switch the sign. I can just drop it.
Is why is where you're pulling the actual number. Like
I'm not pulling the negative sign out of it. So what this negative sign right here,
Yes.
it's coming from the operation of the absolute value. So that's where, like, that was why the x's were. Right.
That's why it's asking to do this.
That's the absolute value goes to those two things. So the key for this problem is that 8x minus 7 is 8x minus 7, the negative version of it when x is less than 7/8. And the 8x minus 7 is just that when x is greater than 7/8. That's what we just determined. So when it was less than 7/8 and 0, I have to put that in there. The other one I don't.
Oh, okay.
Yes, the negative sign is taking care of what the absolute value does by getting rid of the negative sign. It's the mathematical way to get rid of the negative sign, because when you were taught absolute value growing up, I guarantee because I did it, every teacher said the absolute value just gets rid of your signs. Because I said that too. Technically, they don't. Technically, you're multiplying it by a negative to get rid of it. All right, so if we did this one, this one ends up becoming, that one ends up staying the same. That's still 8x minus plus 7. So in this case, I have the 8x's cancel out, and I have negative 14 over x. And in this case, the limit does not exist because it's an asymptote. Oh, yeah, right. Sorry. I forgot it's 1, not 0. You're right. Technically, I guess we probably could have plugged 1 into the original problem.
Yeah,
But
that's why I just changed around the first one.
yeah, technically you could plug 1 into the original problem and be done with it because x is 1. I didn't even think of that until I did it. I know that was not what you were looking for anyway. You were looking for exactly what I did there, so that was fine.
Yeah.
So the answer actually would be negative 14 in this problem. So, all right. So yeah, that's the key with the absolute values. And when you see an absolute value, you have to work with where is it going to be negative.
Go back to the last.
Yeah.
You were on. That problem.
There you go. You're welcome.
The problem using actual log.
Something of this, if I'm going over, yes. That's what I was doing. All right. Move it inside? Yes. That's actually exactly how we want to do this problem. So you have a function inside of a function with the x in there too. So it's like you do not want to try to do this all at once. We want to move from the inside out. The other key piece of understanding here to catch is that it's not from both directions. It's only from the right. That's actually extremely important because limits do not exist on the negative side. I mean, the logs do not exist on the negative side, not logs. So ln of 0 or ln going backwards does not. So we can only come at it from the right. So we're going to change this problem to this. We're going to move the limit inside the tangent. You can, but it's not going to help you that much. All right, so what's happening to ln of x as we're getting closer and closer to 0. Again, the nice thing is if you can't remember, you could always graph. Okay? What happens as you're getting closer and closer to 0? Anybody know off the head? It goes to infinity or negative infinity. Okay. So as we're getting closer and closer to 0, ln of x is getting closer and closer to negative infinity. Remember, ln is the inverse of e to the x. So an e to the x, as you're getting closer and closer to negative infinity, you're getting closer and closer to 0. So ln, since it's the inverse, those two reverse. So as you're getting closer to 0, you're going to negative infinity. So this in here is going to negative infinity. So which value of arctangent, what's the arctangent of negative infinity? So which value of which angle, when you look at tangent, is going to give you negative infinity? Tangent's what? Right? Sine or cosine. So, yeah. And we're looking for the arc. So obviously it can't go to negative infinity because it doesn't. But to go to negative infinity, in essence, I want this bottom. I'm looking for the bottom to get closer and closer to 0. So which value of cosine is going to give you 0? Pi over 2. Or what's the other one? 3 pi over 2. The domain's restricted for sine and cosine, yes. And it's restricted when we're looking at the inverse. So yes. So the question is, but it's restricted from something to something. So it's actually restricted in this case from the first quadrant and the fourth quadrant for tangent. So technically it's not 3 pi over 2, it'd be negative pi over 2. Because that's where the domain restrictions are. I figured honestly I wasn't going to totally break your minds and try to have you remember that part. So no, so the inverse of the functions have to work. So for cosine or for sine and tangent, it's the domain is from negative pi over 2 to pi over 2. So the fourth quadrant, the first quadrant. It's right around the x-axis or the y-axis. For cosine, it's 0 to pi, because that's going to give you every single value in between it, because it would go from positive 1 to negative 1 in cosine, where sine would go from negative 1 to positive 1, and tangent actually goes from negative infinity to positive infinity. So the key question when this one is that pi over 2 will give you 0 for both the cosines and the bottom. Which one's going to give you a negative 1 on the top? And that's this one. Or negative pi over 2, depending on which way you want to go. So if you were to graph tangent, so you could actually see it. Because remember, we're looking at, in essence, the opposite of it. So, yeah. Right. So if you look at the graph of this, you can see how it goes. It's basically shooting up and down. And that's pi over 2. And that's, or negative pi over 2, and that's pi over 2. That's the difference between it. So it's going to negative infinity at negative pi over 2, or from 0 to 2 pi, it's 3 pi over 2. Either one of those answers I would have accepted.
I did not.
Okay. Do you understand how I got the negative infinity? For the limit of tangent of x? I mean, ln of x.
Oh, yeah.
So, okay, so you got the negative infinity part. Awesome. Okay. So remember, as if you're looking at a fraction,
I don't understand it.
I know. I'm going to take a step back. If we're looking at, let's just say 1 over x. As if we're looking at 1 over x, as x is getting closer and closer to 0, what's happening to this number? It's getting bigger, right? That's what we know. So as that gets closer and closer to 0, this fraction gets bigger and bigger. Okay. So if that fraction gets bigger and bigger, that's going to positive infinity. Okay, right? Okay. If that was a -1, it would be going to negative infinity. Awesome. All right. So arctangent is the inverse of tangent. So in essence, this is the answer. And it's going to give you the angle. Okay? What you typically do in trig functions is you're given the angle and you need to tell me what the answer is. Like if I gave you the sine of pi over 2, you tell me the answer was 0. I gave you the sine of pi over 4, you'd say it's square root of 2 over 2 or whatever. That's that unit circle that you did.
Yeah.
Remember that?
Yeah, I can see that in my.
Okay, awesome. Arctangents are, it's just the opposite of that. So instead of them putting the angle in there, they're giving you the answer, and I need you to tell me the angle. Okay, so the question ends up coming out to be is which angle, because sines and cosines are really easy to work with. So if I had sine of x over tangent of x, or tangent over cosine of x, equals negative infinity. Which angle, which x is going to give me negative infinity? Okay, that's what it's asking. Instead of me plugging negative infinity in there and getting the answer, you're going backwards. That's what the arctangent does, or arcsine or arccosine or anything. It's just going backwards. So when we're looking at that, I'm going to rewrite this in a second. Since I'm going to infinity, this goes to 0. Right? Because that's what we just showed a second ago. As the bottom goes to 0, it goes to either, that was that 1 over x. As that goes to 0, this whole thing goes to infinity, right? You understand that piece?
Yeah.
Same thing here. So as cosine of x goes to 0, this whole fraction's got to go to infinity or negative infinity.
Is the limit still in front of?
Yes.
Is that what I'm at?
Yes.
That's
Yes. The limit's still there. I'm just not writing limit a million times.
all of a sudden.
Okay. Okay. So the bottom goes to 0. So which angles give me 0 in cosine? You got it now? That's the pi over 2 and 3 pi over 2.
I didn't see the limit.
Gotcha.
I thought you said you're moving a little bit inside, so aren't we just finding?
You are. Correct. It does. It's 3 pi over 2 or negative pi over 2.
So we can actually, and if no angle will actually.
So remember, we're only going from one direction, right? We're only going from the right. So if you look at the graph, as I'm coming from this direction over here, the right, what's happening to our tangent? It's approaching, well, in this case, negative infinity. It's slowing down. Yeah.
What?
So which value is it approaching?
-1. Oh, there is actual x value. Like it doesn't say the limit. That's why I'm.
Okay, so because you can never actually do negative infinity. It's the limit as you're getting closer to negative infinity. It's just like the limit of the limit of L of x doesn't it never reaches negative infinity because it can't reach negative infinity.
Like, are we just moving the limit?
Yes, kind of, yeah.
Okay, so it's not like we're actually evaluating. for
No,
the
you can never evaluate an infinity.
Okay.
You're always looking at as it's getting closer to it, what's happening. Okay, so yes, you can never evaluate infinity ever because infinity is not a number. You're always looking at it as it's getting closer to infinity, what's happening. That makes sense now?
That's actually the other condition.
Okay.
Okay, so we're just moving the limit back.
Yeah, you're just moving the limits around.
So that's the adequate limit of sign. 0 to 0, is that what you're gonna- over the limit of
Okay.
sign?
I will rewrite this.
Maybe that's simple, because, like, if you're finding the limit, like extension is 0 feet, right?
That's how that would be properly written.
Right, and that would give us.
Correct.
It
Yes.
would sit here. I think that's what I'm- like,
But so you're never getting to negative infinity. You're looking at what's happening to the function as you're getting closer to negative infinity.
Like, okay.
No, it's fine. This is the problem with infinities. Infinities are weird like this.
I don't understand the trigonometry. The part where you have sine x over.
All right, well, that's fine. We're here. Everybody good to hear? Okay. So we know that tangent of x is sine of x over cosine of x. Right? Yes, everybody agree with that?
From as x approaches 0. I didn't see that you switched it to as x approaches negative.
Correct.
Oh, I didn't.
Okay. That's fine. Okay, so we got that. You understand tangent
Go back.
this one? Because this is going to negative infinity. This piece right here, as x is going to, this is going to negative infinity. As ln of x gets closer to 0, as the x gets closer and closer to 0, that function is going to negative infinity. Correct? Okay. We can never evaluate at negative infinity. We can never evaluate at infinity because they don't exist. So you're always evaluating as the limit's getting closer to infinity. Okay? So technically, I can't plug negative infinity into arctangent because it can't evaluate at negative infinity. So you look at what's the function doing as I'm getting closer to negative infinity. And actually, I forgot the little plus there, still from the right. Okay? Because I'm still going. So what's happening, basically, looking at this function here, is this, I'll actually put the arctangent. That's arctangent. You are. Okay, the original, okay. It's fine. All right, there's ln of x. What's it doing as you're getting closer to 0? It's going towards negative infinity, correct? As I'm getting closer and closer to 0, it's getting closer and closer to negative infinity, correct? That makes sense? Everybody good there? Okay. Okay. Here's arctangent. And what happened to my, did this, oh, there it is. Okay, I'm like, wait, what happened to my, okay, because I need, okay. All right. Okay, so as ln of x is getting closer and closer to infinity, or 0, it's getting closer and closer to negative infinity, correct? So I'm taking that information that I just got, and that's going in there. That's where that limit as x goes to negative infinity comes from. Because as I'm getting closer and closer to 0, this is getting closer and closer to negative infinity. That's where that became that. You have to know that the ln of x, yeah, that is one of those assumptions that you know what the graph of ln of x looks like. What I said is if you don't, you can use the graph to remember.
Yeah, I'm not understanding how it goes from the top.
Okay. Let me try to figure out another way to say this.
Because I understand that we're finding is x equals to 0, y is approaching the negative infinity.
Okay.
I get that.
Okay.
I'm almost a little embarrassed.
No, you're fine. And honestly, this is the tricky part about the infinities, because it's hard to grasp infinities because it's not a number that we can just evaluate. So everybody understands how this is going to negative infinity. You're never equaling negative infinity. You're approaching negative infinity. Okay? Does everybody understand? There's a distinction there. You never equal negative infinity. You are approaching negative infinity. Does everybody understand that? Okay. How would you write you are approaching negative infinity in math? You have to use a limit, right? The only way to show that you're approaching something is a limit. Okay? Does that make sense? Yes? So that's what I did here. That statement right there, the limit as x goes to a negative infinity, is me approaching infinity. I could have technically used a different letter if the x is messing you up. I could have used A, I could use B, whatever letter you wanted. But that's how you write I'm approaching something, is the limit. Okay? So all this is saying in here is I'm approaching negative infinity. Okay? Yes or no? How would you say approach? Do you understand approaching means limit, right?
Why that's happening? I don't think I understand the argument.
We're not even, forget the arctangent. So we'll actually, just looking at the limit as x goes to 0 from the right of ln of x. Just looking at that. The answer to this question is the limit as x goes to infinity of x. That is the proper, or negative infinity, sorry. Let me actually. Or I typically will just write it as that. That right there is the same thing as saying that. I'm approaching negative infinity. I notice I didn't put an equal sign in there. Okay? That means I'm approaching negative infinity. This is the proper way to write approaching negative infinity. Okay? So that's that. Forget the arctangent altogether. That would be the answer of the limit as x goes to 0 of ln of x. Okay? I can now do whatever I want with that. And that's what this problem asked you to do. This problem said, okay, you've got that answer now. What's the arctangent of that answer?
Great. You're- great. If the limit has x goes to 0 of x,
Yeah.
in an equation.
Correct. Correct. Right. You have to say you're approaching it. Okay. So now, what is tangent when it's getting closer and closer to negative infinity? What's tangent getting closer to? If you look at the graph of it, it's getting closer and closer to -5/2. You could, I could move it outside here if you wanted to. I could do it that way. Those are the same thing. Because that's easier for you to see. You could definitely write it that way.
Yeah, sorry about that. I just
You're fine.
understood why-
Are we going to have to write it out? That's the point of
You have to tell me the answer is negative pi over 2 at the end.
But can I get negative pi over 2 with the answer by looking at it? Just give you the word 2.
As long as you somehow show me what you're doing, that's fine. So like, there's a couple different ways that I've shown, like,
I don't think I. Right.
oh, with the cosines and stuff,
Yeah.
that's fine. I was doing that. The only reason I was showing you that because I was assuming you didn't understand what arctangent was, so I was trying to explain to you what arctangent's doing. So yeah, either way of these would be fine. Like as long as the work you're putting down shows me your understanding of what's going on, and I can follow your logic from the work to the answer, and that is mathematically correct, you are fine. Okay, so you could say, I looked at the graph and it goes to negative pi over 2. That's fine. You could say, I looked at the graph of ln of x and it goes to negative infinity. That's fine. I actually erased, hold on. Let's see how far I can go back. Oh, okay, that was the last one. There you go. You know, that was the original work I did. So either of these two, I would actually have accepted. Are we good now with the infinities? At least somewhat. Okay. Yes, you can use Desmos on the test.
So I also put in the arc. If I can compute that back to.
So for this one, for some trig functions, yes, that would work. Some it won't. Like we said with cosine, remember cosine oscillates. So doing that wouldn't work. Right, but you wouldn't know it wouldn't exist by just plugging in a number. That's what I'm saying. There is possibility that plugging in a number, even if it's insanely large, is going to give you an answer, but it's not the right answer. That is a possibility. That's why looking at the graph a lot of times will help with that. Because again, when you're looking at, when you're doing the limits by table, which is in essence what you're doing, you're going to plug in a bunch of values as they get closer and closer to infinity. And you want to see what's happening as they go there. So you wouldn't want to just plug in one value. You want to plug in a bunch of values, which is what the graph does automatically for you anyway. The graph makes that nice. You can actually see a bunch of points going at and then look for that pattern. And that's what I just did in that one. All right, so let's do.
I realized this was probably what number 8. I think the last part of it.
Oh, okay. I'll give you a minute. Because I don't have one of those like on the test. So let me do the other two problems that are on the test. I'll show you number 8. I know exactly what it's number. It's actually pretty simple to explain. So, all right. So now let's do limits to infinity. How do I evaluate ones when I have limits to infinity? What was the trick that we used to do that? Dividing by the highest degree on the bottom. Right. So in this case, I'm going to divide everything by x over 3. So the top, I have to move it inside the square root, right? So 1 over x to the 6th plus 4 x to the 6th over x to the 6th over 2 over x to the 3rd minus x to the 3rd over x to the 3rd. So 1 over x to the 6th plus 4. 2 over x to the third minus 1. Right? What's 1 over x as x goes to infinity? What does that happen to that fraction? As the bottom of the fraction gets infinitely large, what happens to it?
Over X six.
That's that. 1 over x to the sixth.
No, it's not. Yeah, six.
X to the third. I divided the top and the bottom by x to the third. But remember when we bring it inside the square root, you basically double the exponent because instead of divided by 2, you multiply by 2. So that's where the x to the 6 comes from.
Yeah.
Remember that the square root of x is just the same thing as saying x to the 1/2. So if I want that to equal 3, the number up top had to be 6. It's all those little things.
I almost failed algebra 2, and I got off straight to calculus.
Yeah.
Algebra.
So on your next slide, whenever you're moving inside a square root, double it. That's the easiest way to remember it. You move inside of a square root, you're doubling it. All right, so now 1 over x, as x goes to infinity, goes to what? It goes to 0. So this is really the square root of 4 over -1, which is -2. The square root of 4 is 2. Okay? Yeah. So make sure I did all of them. That's basically the same. Let's do this one.
Did you go back? I saw you guys picture.
Sure.
Wouldn't it be negative square?
Oh yeah, so it'd be positive too. It'd be positive too. That's right, because that's going to negative, so that'd be -1, -0. So yes, it'd be. You do. Good catch. So that equals positive too. So because you're going to negative infinity, you have to do the negative square root. Because remember, square roots are both positive or negative. Since we're going to negative infinity, you have to do the negative version of the square root. So it's -4, which is positive 2. It'd be -2. Again, what's the easiest way to check your work? What's the easiest way to check all your work with these?
Your answers.
No, that actually won't help you. Just graph it. Just look at the graph. The graph will always show you what's happening. Okay, so you should always look at the graph to verify your work. When I'm saying find, I'm not looking for you to say, I found another graph. Don't do that. You can use the graph to verify your work, but you can't use the graph to actually find the answer for these problems. You can find some answers. You can find some ways. Yeah. Yeah. All right. What about this one? So remember, you can always break things up, right? That's the point with the limit. You can always do limit as x goes to infinity of x minus the limit as x goes to infinity of square root of x. What's the limit as x goes to infinity of x? What's the limit as x goes to infinity of square root of x? We can't do that. Remember, that's one of those indeterminate forms, right? So we cannot do that. Problem is I don't have a fraction. I don't know if that's going to help you. Because if you do the conjugates, you're going to end up getting x squared minus x over x minus the square root of x. The top still is negative is infinity minus infinity. So conjugate is probably not going to help you. And this problem, the problem that I did in class, which probably was a little bit easier than this one, was that. If you saw that, if you think back to your algebra pre-calculus class, what would you do to x squared minus x? I could factor out an x, right? So this would be x and then x minus 1. Now, if you look at it, that goes to infinity, that goes to infinity, and I have infinity times infinity, which I can do. That's infinity. Okay. You can actually do the same thing here. I can pull out a square root of x. I know it sounds weird, but you can. So I can pull out the square root of x, and I end up with the square root of x minus 1. And it's the exact same thing over there. That's infinity. That's infinity. So it goes to infinity.
X will be the square root.
X square root of x times the square root of x is x. So if I distributed that, I would get back to that.
Okay.
The key with these is because I can't do infinity minus infinity, that doesn't work. I want to get it to something with multiplication. Because infinity times infinity or infinity times 0 or infinity times, those I can do. Okay? But I can't do infinity minus infinity. And I can't do infinity divided by infinity. So I got to get to some kind of either multiplication or addition to make my life easy. If that was a plus, you were done. You didn't even have to do anything else to it. But since it's a minus, you do. All right. That was the end of the actual questions that I have on the test. This was number 8 on your homework. And specifically the last question. Because I think the first couple questions you should be able to easily get. So, when you're looking for the asymptotes, you're looking for vertical asymptotes and you're looking for horizontal asymptotes. So we have 2 vertical asymptotes. That's the 2 and the 0. The horizontal asymptotes we're looking at as it's going to infinity. And those would be the 2 horizontal asymptotes. And that's the -1 positive or positive 2.
Them upside down. So I put -1 and 2.
On the x, yeah. You're all so it's really easy to screw those up because typically they think, oh, x is the horizontal axis. So the horizontal, you got to remember where's it going through. So the horizontal asymptotes go through the y-axis. So it's y equals something. The vertical asymptotes go through the x-axis, therefore it's x equals something. That's all that's asking for. All right, I think. I hit everything. And yes, the homework is not technically due until Thursday at 5:30. All right, any other questions?
Are all the questions worth the full amount of points, or does it vary,
Every question's worth 10 points,
including the?
including the really long one.